If an amino acid is dissolved in water and the pH of the solution is adjusted to 12, which is the predominant species present? So, right, this question's talking about amino acids. And so they aren't going to try to trick you on the ACS. They ask about amino acid. All of these answer options are forms of an amino acid. So, right, this problem is going to be about pH and pKa and understanding that concept. So, I'm going to erase some of these answer options to clear up some space on the board here. Right, so, right, so I can try to explain this. Okay, so here is the form of an amino acid without a charge. Okay, and so what we want to think about is the concept of pH and pKa. So pKa, right, if we just have an acid going to an equilibrium with its conjugate base. So the pKa is the pH at which this ratio of acid to conjugate base will be 1-to-1 in solution. If we remember general chemistry 2, right, Henderson-Hasselbalch equation, pH equals pKa plus log the base conjugate acid, right? And so when this is 1-to-1, when you have, I don't know, 500 A minus divided by 500 HA, right, you get log of 1, which is 0. If this guy goes to 1, then this whole thing goes to 0, and then pH equals the pKa. So, when the pH is equal to the pKa of this group, right, then it will be both equal amounts of conjugate acid, conjugate base. So, then we need to think about the pKa's of the functional groups here, right? Which has the potential to act as an acid or a base here. Right, here's a lone pair of electrons here. So right, this guy, we know amines can accept protons, can be bases. Carboxylic acids, right, can act as acids here. And we should have memorized a table from our textbook that looks like this. So for pKa's, less than 0, approximately 5, approximately 10, approximately 15. Right? So this is water. And water, if we just replace one of the H's with an R group, it's an alcohol. So both of those have approximately 15 pKa. Approximately 10 is a protonated amine. So let's say RNH3 would be approximately 10. Approximately 5 is carboxylic acid. Okay, and then less than 0, H3O plus, ROH2 plus, and protonated carboxylic acid, H plus OH. Right, so these are some pKa's you should know off the top of your head. Right, and so in this problem, just drawn here, what do we have? We have, let me draw it, this guy is right over here, this functional group. Okay, and let's see, NH2, well, this is the conjugate base of this guy, right? So we have some pKa's to look at. So if we think, let's go back to the pH pKa deal, right? So HA in equilibrium with H plus A minus, right? So let's say this has a pKa of 7, just this arbitrary acid we're drawing here. So if the pH of the solution is 7, we'd have same amount of HA as A minus in that solution. So what would happen if we now raise the pH above 7, right? So we have an equal amount of this and this in solution. So if we raise the pH above 7, what we're doing is we're adding base, right? We're making the solution more basic. So let's do that, right? We could add, right? That's a base. HO minus, what's it going to do? It's going to turn the acid in there into a base. So if the pH is greater than a pKa, we shift the equilibrium that way, right? So pH greater than pKa will favor the conjugate base, okay? And so likewise, pH less than pKa. Now what we're doing, if we decrease the pH below the pKa, now we have extra H plus in there, and the base can pick up that, which will turn it into an acid, right? So we'll shift the equilibrium back that way. So this is for, let's see, pH greater than pKa. This happened when pH was less than the pKa. Okay, so now we know pKa of this group was about 5. The pKa of, let's just draw this, like, let's put a 3 here, plus, so the pKa of this group is 10 approximately, right, pKa's. And so we're talking about 12, right? So the pH is greater than the pKa for both of these. So we're going to want these in their basic forms, right? Yes. So, right, carboxylic acid, just to make sure we're understanding this in these equations, right, to match it up with this, we have RNH3 plus in equilibrium with H plus R NH2. Right, so here pH is greater than pKa for both of these guys. Right, so we're going to shift over here. We're going to have that form on our amino acid. Let's look at the carboxylic acid. Right, the acidic form here, OH, in equilibrium with its conjugate base RCO minus. Right, so again, pH greater than pKa, shift to the right. We're going to have this form on our amino acid. And let me see which answer option that was. For this problem, if I can find it, let's see, that should be answer option D. Yes, choice D from the beginning of the video. So D is our answer. Right, and we don't see that on the board. But hopefully the concept makes sense. It's important to understand that pH, pKa. Hopefully you can understand it well enough to reason through it on a test, make sense of this. Hopefully my explanation helped.